Hey everybody, Markiplier here, and welcome to Optimization Station, where we dive deep into the world of game development and crank those frames per second all the way up to, well, as high as they can go. We're talking buttery smooth gameplay, lightning fast loading times, and AI that's so smart it might just start writing its own Let's Plays. Over the next few chapters, we're gonna break down the essential techniques to optimize every single pixel of your game, from the tiniest line of code to the most epic boss battle. Alright, first up, we gotta talk about resource management. This is the bread and butter of optimization, folks. It's like, imagine you're playing a real-time strategy game, right? You've got your workers, your buildings, your armies, all vying for your attention. Now, if you're just randomly clicking around, wasting resources, not paying attention to your build order, well, let's just say your opponent is gonna steamroll you faster than you can say, supply depot. We need to squeeze every ounce of performance out of our game, just like squeezing every last drop of value out of those minerals and gas. We're talking efficient pathfinding algorithms so your units aren't taking the scenic route. We're talking micromanagement techniques that would make a StarCraft pro proud. Remember, every CPU cycle counts. Now let's dive into the nitty-gritty, the nuts and bolts of your game, the code. This is where things can get really hairy, really fast. We're talking spaghetti code, tangled messes of logic, functions nested inside functions like a digital Russian doll. But fear not, my friends, because we're gonna untangle this mess together. We're gonna be using data structures like arrays and hash maps. We're gonna be simplifying those complex problems with some good old-fashioned dynamic programming. And, you know what the best part is? We're gonna be using profiling tools to identify those pesky bottlenecks, those lines of code that are slowing everything down. We're gonna optimize the heck out of them, reduce that computational complexity, and make your game run faster than a cheetah on an energy drink. Alright, next up we gotta talk about frame rate and latency. These two factors can make or break your gaming experience, especially if you're aiming for that competitive edge. This is especially crucial for all you competitive gamers out there, where every millisecond counts. Imagine being in the middle of an intense match and a slight delay causes you to miss that critical shot. Frustrating, right? We're talking about that silky smooth 60 frames per second, that feeling of responsiveness where your actions translate instantly on screen. It's the difference between a game that feels sluggish and one that feels like an extension of your own reflexes. No lag, no stuttering, just pure, unadulterated gaming bliss. When your game runs smoothly, you can fully immerse yourself in the experience, reacting to every movement and sound without any distractions. Now, achieving this requires a delicate balancing act. It's not just about cranking up the settings to the max, it's about finding the right balance. We need to adjust those graphics settings, find that sweet spot between stunning visuals and blistering performance. Sometimes, lowering a few settings can drastically improve your frame rate without sacrificing too much visual quality. We need to optimize our network settings, reduce that ping so low it practically begs for mercy. A stable and fast internet connection can be the difference between victory and defeat in online matches. And of course, we need to manage our system resources like a hawk, making sure nothing is hogging precious processing power. Close those unnecessary background applications and keep an eye on your CPU and GPU usage. We're talking shadow resolution adjustment, texture optimization, the whole 9 yards. Every little tweak can add up to a smoother, more responsive gaming experience. Because in the heat of battle, every frame counts. Whether you're dodging bullets, landing headshots, or executing complex strategies, having a high frame rate and low latency can give you that crucial edge over your opponents. Alright, let's talk about multiplayer games. Because what's more fun than dominating your friends online, right? But here's the thing, network performance can make or break a multiplayer experience. Lag can turn a tense firefight into a slideshow, rubber banding can make you feel like you're stuck in a time warp, and disconnections? Well, let's just say nobody likes a rage quit. That's why we need to optimize our network code like our lives depend on it. We're talking predictive algorithms that anticipate player movement, lag compensation techniques that smooth out those hiccups, and optimized communication protocols that send only the essential data. We need to reduce packet loss, manage congestion, and make sure our players stay connected and engaged, ready to teabag each other for all eternity. Now let's talk about AI. Because what's a good game without some challenging opponents to test your skills against? AI has become an integral part of modern gaming, providing players with dynamic and engaging experiences. Whether you're playing a first-person shooter, a strategy game, or an RPG, the quality of the AI can make or break the game. But here's the thing, AI can be really dumb if it's not implemented properly. We've all encountered those moments where the AI just doesn't live up to expectations. We've all been there fighting against enemies that just stand there like they're brain dead, or bots that run in circles like they're trying to win a prize for most confusing pathfinding. It's frustrating and can take you out of the immersive experience that games strive to create. That's why we need to optimize our AI and bot behavior, make them smarter, faster, and more unpredictable than ever before. This involves a deep dive into AI behavior settings, tweaking and refining until the bots can provide a real challenge. We're talking decision trees that allow them to adapt to different situations, making split-second decisions that keep you on your toes. These decision trees are like the brain of the AI, processing information and reacting in real time. Machine learning models that help them learn from your every move, evolving and becoming more challenging as you play. Imagine an AI that studies your strategies and counters them, forcing you to constantly adapt and improve. And pathfinding algorithms like A** that ensure they navigate the game world with the grace of a gazelle and the cunning of a fox. These algorithms allow AI characters to move seamlessly through the environment, avoiding obstacles and taking the most efficient routes. We're gonna make those bots so smart they'll be challenging you to chess matches in your sleep. Imagine a future where AI opponents are not just a part of the game, but a true test of your skills, pushing you to become a better player with every match. The possibilities are endless and the future of gaming AI is incredibly exciting. Multi-threading and parallel processing, unleashing the power of the multi-core. Alright, let's talk about multi-threading and parallel processing because in the world of game development, more cores equal more power. Think of it like this. Your CPU is like a car engine, and each core is like a cylinder. The more cylinders you have, the more horsepower you can generate, and the faster your car can go. Now most modern CPUs have multiple cores, but if your game isn't designed to take advantage of them, you're essentially driving a sports car with the parking brake on. We need to unleash the full potential of our hardware, and that's where multi-threading comes in. We're gonna split those tasks across multiple cores, enhance performance, and make sure our game runs as smooth as a freshly paved racetrack. Chapter 7. Game Engine Optimization, Fine-Tuning the Beast. Alright, let's talk about game engines, the very foundation upon which our digital worlds are built. Now, game engines are incredibly powerful tools, but they can also be resource hogs if we're not careful. It's like trying to run a marathon with a backpack full of rocks. We need to lighten the load, optimize our engine settings, and make sure everything is running as efficiently as possible. We're talking dynamic resolution scaling, which adjusts the rendering resolution on the fly to maintain a smooth frame rate. We're talking object culling, which prevents the engine from rendering objects that are outside of the player's view. And of course, we're talking texture optimization because nobody wants to see blurry textures. We're gonna fine-tune this beast until it purrs like a kitten. Chapter 8. Procedural Content Generation, Building Worlds on the Fly. Alright, finally, let's talk about procedural content generation, because who needs handcrafted levels when you can have a game that builds itself? Imagine a world where every time you play, the experience is fresh and new with landscapes and challenges that are never the same twice. That's the magic of procedural generation. But here's the thing, procedural generation can be a double-edged sword. While it offers incredible flexibility and replayability, it also comes with its own set of challenges. On the one hand, it can create vast, sprawling worlds full of endless possibilities. These worlds can be so expansive that players feel like they are exploring a living, breathing universe. On the other hand, it can also bring your game to a screeching halt if it's not implemented carefully. Imagine the frustration of a player when the game crashes just as they are about to discover a hidden treasure or complete a challenging quest. That's why we need to optimize our procedural generation algorithms, make sure they're fast, efficient, and don't bring our CPUs to their knees. Optimization is key to ensuring that the game runs smoothly, even as it generates complex and varied content on the fly. We're talking lazy loading, which only generates content when it's actually needed. This technique helps in managing resources effectively, ensuring that the game doesn't load unnecessary data, and keeps the performance high. We're talking caching, which stores previously generated content so it doesn't have to be recalculated every time. Caching is crucial for reducing load times and improving the overall gaming experience. We're going to make sure our game worlds are generated on the fly without sacrificing performance. By combining these techniques, we can create dynamic, immersive worlds that feel alive and responsive, all while maintaining top-notch performance. So, let's dive into the world of procedural content generation and see how we can build amazing, ever-changing game worlds that keep players coming back for more. Optimization Station game on! So there you have it, folks. The essential techniques to optimize your game and create an unforgettable player experience. Remember, optimization is all about finding that perfect balance between performance and visual fidelity. It's about squeezing every last drop of power out of your hardware, while still delivering a game that looks and feels amazing. Now go forth, my fellow developers, and create games that will blow the minds of gamers everywhere. And as always, thanks for watching. Like and subscribe for more game development insights, and be sure to check out the description for links to all the tools and resources we talked about today.